Thank you so much, Lucy, and welcome to everyone to our 2025 online Voice of the Future event. My name's Susie Rabin. I am from the Royal Society of Biology, and we are really pleased to be able to be presenting this session this afternoon with a really wide range of politicians who are going to be answering questions. Just to remind people, the event is being recorded and that attendees in the audience, your camera and microphones are automatically turned off for this webinar. If you do you have any questions you want to send through to RSB staff, then do please pop those in the Q&A, but do bear in mind we're not able to accept any new questions for our MPs and Lords that haven't been submitted so far. We're really pleased this afternoon. We've got a wide range of early career researchers who will be asking their questions directly to parliamentarians, as well as some future early career researchers. So we've got some pupils from Bishop Hatfield Girls' School, and these GCSE and A-level students have sent in some questions in advance for me to pose to the politicians on their behalf. So yeah, welcome to the pupils from Bishop Hatfield Girls' School, and also to their teacher, Dr. Ali Boone, who was our RSB biology teacher of the year last year. So really pleased that some of her A-level and GCSE pupils are joining us this afternoon too. So we're hoping our first session will be with the Minister, Lord Vallance, who we have worked with quite a few times over the last few years. And this is a sort of key opportunity for early career scientists and engineers to sort of quiz political figures at the House of Commons and the House of Lords about science issues that really matter to those. We've been running the event since 2012, which is definitely long before many of us were at RSB, but it's a great event we've been doing quite a few years now. We are organising the event with quite a few of our organisations from the Parliamentary Steering Group. So we do have yeah, brilliant. Thank you. So these are our member organisations who are taking part this afternoon, who have sent us some early career researchers who are taking part this afternoon, as well as Bishop Hatfield's Girls' School, and yeah, so quite a wide range of organisations who are taking part. Yeah, we do actually have the shadow minister, Ben Spencer, has actually popped up. So Ben, I don't know if you'd be happy to take an initial question whilst we see, yeah, if Patrick is able to join us as well. So yeah, welcome. Dr. Ben Spencer is shadow Minister for Science, Innovation and Technology. Welcome. So we do have a couple of initial questions from the GCSE and A-level pupils at Bishop Hatfield Girls' School who would like me to ask a couple of questions on their behalf. So if you're happy to kick off with that, the first question actually is from the pupils of Bishop Hatfield is, did you enjoy science at school?
Well, thanks, Susie, and thank you so much for inviting me to come and speak and answer questions of Voice of the Future. The first question, did I enjoy science at school? So that's, I don't think it's a sort of official sort of state secret. So science was where it was at for me when I was at school. And in fact, I often say that I tried to shed my non-science subjects as quickly as possible. I managed to succeed that once I hit my A levels, so just focused on STEM subjects. So yeah, no, I absolutely adored doing science at school, and it was, for me, love of science has been not just a sort of academic inverted commas interest. It's also been, something that I've been exposed to at home. My dad was a space engineer. So I grew up in seeing, hearing about the science and engineering that he was doing. There was always a car which was being rebuilt in some way, shape, or form, or fixed in our garage for me growing up, or some project my dad was working on. And I remember even to this day, one of the Christmas presents, my number one request for a Christmas present, I think when I was about 8 or 9 roughly, was to have an encyclopedia of science, so that I could tutor and learn that. And then various different chemistry sets that I got in my sort of early teenage years and experiment with that. So science of all different types. I've just had an absolute passion for, and even now, whether it's reading popular science stuff, trying to understand general relativity, which especially for the school children who are listening through, I thought I understood general relativity to a sort of large extent when I was sort of in my late teens, early 20s, but increasingly the more I think and try and learn about it, the more I don't understand it, which is really cool. And for me, I think that's one of the most amazing things about science, because the starting point is that everything we know is wrong, and it's almost like a philosophical starting point. So no matter how advanced and how clever and how much we think we understand about the world, there is a sort of hope, and it's a weird sort of hope, which is our understanding is incomplete, and who knows what could be around the corner? Who knows if some science experiment's going to completely turn everything round and turn out that actually electrons don't really exist, or gravity isn't really a force, or the speed of light isn't the galactic speed limit, or something really amazing that could be just around the corner. So I think it's dreadfully exciting, and there's not a day that I don't use or think or imagine about science in some way, shape, or form. And of course, then I also read sci-fi when I occasionally read novels and stuff. And when it comes to watching TV, sci-fi is my definite go-to. So yeah, I don't know how much more I can
No,
unpack
no, no.
that answer.
That is brilliant. And that I think leads on to actually my second question, which is again from the pupils at Bishop Hatfield Girls' School, which is, do you have to know all the latest developments in science as part of your job?
Well, who could? Who could? I mean, thankfully I don't, because I don't think it's possible to know all the latest developments in science. But what I do need to do is, it's helpful for certain areas for me to have a bit of an understanding, a basic understanding of some of the science and technology that people are talking about. So at the moment, there's a lot of focus on AI and large language models. It's useful for me to understand the basics about, how those work, some of the limitations around it, some of the challenges, and have that sort of broad brush sort of scoping overview. And to understand, particularly when it comes from a policy perspective, what are the challenges in terms of delivering science or delivering these technological changes, which, whether it's the people, the training, the energy, the supply chains in terms of loads and loads of advanced chips, how that works, the regulation of things we need to think. So it's a bit, some areas I've got a bit more of an in-depth understanding, but there's so much. I mean, who could know about it all? Maybe one for a different life, eh?
So, Amelia from Applied Microbiology International, would you like to ask Ben your question, please?
Hi there. My question is that antibiotics underpin all modern medicine, but resistance is a constant threat. The current economic market for new antibiotic development is struggling, and companies do not find antibiotic research to be attractive or profitable. What would you like to see the government do to ensure that research is undertaken to develop novel antibiotics?
Thanks. So good question on antimicrobial resistance. And if I may break it down into sort of three areas. So I think firstly, we need to make sure that we limit antimicrobial resistance as much as possible. And look, I speak as someone who used to be a former doctor, and very much I don't think my former medical school teachers would forgive me or others if I didn't talk about the importance of rationing. Well, it's not so much rationing, because we call it rationing prescribing, but what that really means is being very mindful when antibiotics are prescribed, in terms of the right antibiotic for the right illness, but also not over prescribing antibiotics. And also the educational part of that, which is, a lot of conditions aren't bacteria related, they're virus related, and don't get better if you take antibiotics, or antibiotics aren't necessarily going to help. So often going to pharmacists is the best way of getting help for especially mild conditions, and not antibiotics aren't always the answer. And I think that's a really important thing just to keep on reiterating, because there's no point developing new antibiotics if we're always going to be chasing our tail with the challenges of emerging antimicrobial resistance. So that's the first thing. I think it's important to keep on driving that. The second thing is emergent technologies in terms of helping with this area. And look, hey, I'm by no means a expert at all, nor would I sort of profess to be in this sort of area. But I think some of the really interesting things that are happening in the UK biotech industry and industry in general are around the use of novel technologies like AI in terms of speeding up drug evaluation and drug finding processes. So this is getting AI to look through. You've got a whole bunch of candidate for the people who aren't sort of for the obviously I know you're an expert, Amelia, but just for everyone else on the broadcast. For people, you've got a whole bunch of molecules that may or may not have some antimicrobial effect, using AI to thin down the ones which are worth doing animal trials and then human trials, or to just really what I think is one of the most amazing developments in the past few years, the protein folding models to help a sort of more top-down approach to drug design. So instead of saying, well, here's a lot of different molecules, let's just test and see what happens, to have a bit more structured design when it comes to novel agent production. And I think for that, clearly there's a whole lot of bigger questions that need to go into making sure that we've got domestic computational capacity, we've got energy, we've got people who can use this technology, who can keep on developing this technology, in a whole ecosystem that's around that. And I think that future, and it's not just for antimicrobial research, I think it's for medical research more generally, from cancer through to all sorts of different treated conditions, I think is really exciting. And then there's the third part, which is making sure the markets work, because we rely on the pharmaceutical sector to spend a huge amount of money at risk to develop novel drugs and novel treatments. And we've got to make sure that there is if they're going to gamble, and it is danger money, a lot of this money which is going into novel drug development, whether it's antibiotics or whatever, that there's a system at the end where, once something has been found and discovered, that they can get their losses back and make a profit from that drug. And I think we shouldn't be. Sometimes pharmaceutical companies get a bad rap on this, but it's important that we support our pharmaceutical companies, and they can risk the huge investment they have to. I think I can't remember the stats, so like 1 in 100 drugs or something, actually make it to market in the end. But to make sure that they've got the benefit from investing the money that they need to invest to develop these new drugs, which we all depend on.
Brilliant. Thank you so much, Ben. Our next question is Nicola from the Biochemical Society. Do you want to ask Ben your question, please?
Hi. What would you like to see the government do to address the growing skills shortage in STEM, particularly among underrepresented groups?
Thanks, Nicola. That's also a really great question. It's one that's really close to my heart, because before, last Parliament round, and before I was a Shadow Science Minister, I did some work supporting the Association of Science Discovery Centres. So these are what is thinking about it's science sort of experience museums or environments or facilities, and I'm sure you can think of them, and then there'll be some you expect, from the Leicester Space Centre to the Winchester Science Museum, and they're places where younger people and adults, for that matter, but predominantly aimed at younger people, can go and learn the practical interactions with science and demystify science to a certain extent. I think there's a real problem that a lot of common cultural perspective of what a scientist looks like, and I'm sure if you ask a sort of so-called person on the street what a scientist look like, you'll conjure up some sort of stereotype of a fellow with a beard, with a lab coat, looking sort of slightly awkward and geeky, etc. Not representative of just the diverse range of people and who are in science, and I think sometimes there is there's a real danger that a lot of people can think science isn't for them, or engineering isn't for them, or maths isn't for them at an early age because of either no one in their family does it. It's culturally sometimes got probably a bit of a bad rap, or they just haven't been exposed to it. And this is predominantly for girls, and it's predominantly for people from Black and minority ethnic backgrounds. And I think science discovery centres, but also experiments in school, going on field trips to science, to see science in action and engineering in action is really important, because especially the younger, the better, because I worry that a lot of people end up closing off in their own mind doors or avenues to pursuing a career in science, technology, engineering, or maths because of perspectives that it's not really because of assumptions about who they are in themselves, when really, I want the joy and the excitement and all the benefits of science to be available to everybody. And so I'm a huge fan of what are called enrichment experiences, which is for people who haven't grown up surrounded by science. I was lucky, although to be fair, if I hadn't been surrounded by science, I'm sure I would have gone down that pathway anyway in my particular case. But there's a lot of people who aren't surrounded by science who don't necessarily know that much about it. And the more you see of science and the excitement of it, I think can really, really inspire and try and demystify some of it, and to show that science really is for everybody.
Brilliant, that's great. Thank you, Ben. And yes, I think at RSB we're very much in the belief that science is for everyone. So we are keen to encourage and support the next generation of scientists as well. So I think the next question, we have Leah from the Society of Chemical Industry. Do you want to ask Ben your question, please?
Hello. So 2024 and 2025 has not been the greatest year for several UK-based businesses. A lot of businesses had to cut back on several initiatives due to increased fixed costs, but also to the lack of talent recruitment with specific skill set. It has been increasingly difficult to recruit the right talent, especially in Yorkshire and Northeast. And many people feel STEM qualifications are not really appreciated by employers, and the number of students that select the STEM degrees keeps dropping. So how can we tackle this in the UK and to invest in growth by nurturing the right skill set?
Cool. Thanks, Leah. In some ways, I think that's there's some overlap with the previous question I was just asked about the skill shortages and getting people into STEM, and there is a big STEM skill shortage. It's one of the big challenges that we face as a country in terms of how we can encourage and support more people to take STEM careers. Obviously, businesses have really struggled over the past year, particularly with some of the government's budget decisions and taxation decisions. And certainly it's, what I hear from a lot of companies who I speak to in all different sectors, the challenges it's providing. There is a sort of curiousness about it in terms of what you've just said about employers, because the employers I speak to, they are desperate to get people with STEM skills and backgrounds into employment. I mean, it's in terms of employability and the need for it. I mean, there's a real desire. So these are doing qualifications in STEM, whether that's at university or at a sixth form college or for apprenticeship. And I think we need to talk more about all the different ways that people can get training in STEM. Not only the university route, that's important, but it's part of the package of STEM training, that the skills that you learn are highly valuable and desirable by employers, but also very transferable more generally. So I've got science qualifications. I've also got a science PhD. There's not I struggle to think of a day that I don't use the skills that I learned in my science PhD to carry out my job. And going back to what Lord Patrick Vallance said, I think it's about science and politics. I think he's right to say that we should keep politics out of science, but certainly politicians benefit from well, I guess I would say, wouldn't I, from science skills and science education in terms of looking particularly at looking at data. You're absolutely right to push that we need to tackle this STEM skill gap. I do think a chunk of it is for our own domestic workforce, making sure that people, firstly, there's the career pathways, sorry, the education pathways for them, but also making sure that they don't rule themselves out of it. And again, I'll go back to what I was saying about enrichment activities at school, supporting science. I'm struggling. I'm trying not to say detoxifying science because I don't want to be sort of taking out of context. But it's also sort of what I am. If you can think of another word for me, I can see you nodding, Leah. But you know exactly what the whole point I'm trying to get at. I think in some parts of our society, science gets a bit of a bad rep and is seen as a negative, and we need to, or it's seen as not something that particular types of people do of particular backgrounds, and we need to get beyond that. And do you know what, actually, just before I came onto this Zoom, I was doing some research because I wanted to talk a bit about role models. And I'm trying to, famous, scientific role models for young people as part of the inspiration. And I wanted to talk about female role models. And I was thinking, who are the amazing women in science I can think of who I could talk about in this call? Obviously, Rosalind Franklin jumped into my mind, and Marie Curie. But like those were, and there's a few like, Elizabeth Garrett Anderson, etc. And there's, people in medicine, etc. But it's much easier to think of male role models than it is of female role models. And also, I'm also wondering, and forgive me on this one, I'm very interested to hear what people on the call think about this. About 100 years ago, a lot of science was an individual activity where you could sort of do a piece of research on your own and you could get a sort of success. And we've got a lot of sort of very successful, famous scientific people who were sort of weren't part of, well, somewhere, but it was a bit more solitary in terms of people's endeavors and people's achievements. Where now science has changed quite a lot. It's very collaborative. It's very research teams and research groups, more so than it was a century ago. And I wonder if that's caused a more difficulty in terms of being able to pull out real scientific leaders and role models that we want to sort of like inspire our kids with. And because 100 years ago it was predominantly all blokes, because that was the society that we lived in, and not just for science, it was all different areas. I mean, I know there's some women who did great things, but it was just the way our society was. It was mainly, mainly fellas. Maybe because we've now got that collaborative system, we've got a bit of a challenge that when you look back on our history, you've got one side of the story, and it's not because there weren't women can do science any less or better than men. It's just that women didn't because our society was, because of the difficulties to be a successful woman or to go down that pathway.
Thanks, Ben. Yeah, some really interesting points there. It's sort of, some quite big stories. But I think yes, we have a point from someone in the audience has said maybe it's stories of teams, or the role of women has possibly been erased more recently, or we haven't, those big famous characters are very much from history rather than more recently. But hopefully our earlier career researchers online now can be part of. We have a lot of women actually taking part in this session. I think most of our early career researchers this afternoon are actually female, so hopefully they will be the faces of research discoveries to come in the next few years, which we'll definitely be looking forward to see. I think next we have Aisha from the Royal Society of Chemistry. Do you want to ask your question to Ben?
Hi, thanks, Susie. My question is, how important is upskilling the current regulatory workforce in addressing emerging environmental issues like contaminants of emerging concerns in water?
Yeah, thanks for this question. I mean, it's a bit of a straightforward one to answer in a way, in that any regulatory organization or body needs to make sure that it's able to discharge its statutory duty when it has a statutory duty to regulate, whatever sector that is, and whether that's science or environmental issues. And it's on them in terms of making sure that they've got the right people with the right training and ongoing professional development. I don't necessarily think the government or politicians should be saying how that is done, but certainly any regulatory body, whatever it does, needs to have a workforce that can carry out its duties, and the level of skill or specialist educational experience requires going to depend in terms of what they're trying to regulate and the environment and how quickly that's changing.
That's great. Thanks, Ben. We have a couple more questions on we've got one actually on net zero next. So Leah from the Society of Chemical Industry, do you want to ask your question?
Yes. So the cost and difficulty of reaching net zero is becoming unsustainable. Companies are trying to launch projects to reduce their greenhouse gas emissions for their products, but many of them had to cut back on the 2030 and 2040 goals. What would a future conservative government do to back incentives that will allow companies to keep on this track and not falter?
Thanks. So it's a good question about meeting net zero and the challenges about all that we need to do, UK and across the world, in terms of reducing CO2 productions and protecting our environment. I think there's a few things some observations I'd like to make in general. I think firstly, it's important to have ambitions and to have a clear idea of what we need to do, what the world needs to do with regards to reducing carbon dioxide going into the atmosphere. There's no point having targets alone without a clear plan in terms of how you're going to get there and a thought about how you're going to get there. And it can't just be carbon dioxide production goes like this, and then when you hit 2030, 2040, 2050, whatever, or 2050, it goes like that, because you've already got too much. You have to steadily decrease as we go forwards. Then we've got another problem in terms of, as the UK, we compared to the rest of the world, we are, certainly we only do a small portion of polluting. Completely right that we sort out what we're doing, but we can't ignore the fact that a lot of the CO2 production in the world is coming from China, it's coming from America, it's coming from Brazil, it's coming from Iran, and thinking about how we work together in terms of overall carbon productions. There's also no point in having internal approaches which can have perverse side effects. So right now, there's a lot of discussion about the ZEV mandate. I'm a big fan of the ZEV mandate personally. However, if the consequence of the ZEV mandate is that we end up having a lot more Chinese electric vehicle imports, which are being built in a very different environment when it comes to pollution. China is still building coal power plants. So if the consequence of regulating in the UK, Europe and beyond is that we end up essentially just outsourcing our pollution elsewhere, to the detriment of local business, and not really, we feel great, but we haven't really achieved anything. All we've done is just outsource the pollution elsewhere. I don't think that makes sense. And so I think we need to think a lot more about how this works across the board, not just in our own backyard. And, again, I just want to stress, that is not to say we shouldn't be focusing and we shouldn't pay attention to what's happening in the UK and have, work hard on in terms of what we're doing with CO2, but we have to think about how it works on the international scale. And we've got some big challenges when it comes to decarbonisation, stuff that I don't think we're talking enough about. So when it comes to domestic heating, which is a huge challenge, like a huge challenge. Most homes are heated through, gas-fired boilers. The reducing carbon production from chemical production from cement, or agriculture, which is again another one of the big areas of decarbonisation. We've done some great stuff when it comes to aviation and SAF, and the government's taken on our SAF mandate going forwards. But there's bigger conversations that we need to have around that. And like I say, we need to think it through as a broad perspective as well, not just what's happening in the UK, but what's happening in other countries, particularly perversities that could arise. Another example, solar panels. Cheap solar panels come from China again, manufactured using coal power. That's not necessarily, I say not necessarily going to be, but there's a lot of potential for perverse outcomes if you're not careful in terms of how you're approaching CO2 production or CO2 reduction.
Brilliant. That's great. Thank you so much. So we've got one final brief question for you, Ben. So we've got Anne from the London Mathematical Society. Do you want to ask Ben your question, please?
Yes. Oh, wait. Yeah, can you see me?
Yep.
Good. My question is quite short. What can the government and science community do to make PhDs more accessible?
Thanks. That's a broad question. So I was very lucky that my PhD was funded by NIHR. So that was a National Institute for Health Research. So I had a fully sort of public money sponsored PhD, which was brought for me in terms of being able to do that as part of my postgraduate medical work. I would, in some ways, actually, I was really interested by this question, and I'd like to flip it around, which is, where do you think it's not accessible, and what do you think the challenges are? Because I'd really like to know where you see the barriers are, because I wasn't aware that there was an accessibility necessarily issue in terms of doing a STEM PhD. So I'd be really grateful to understand a bit better what you think is the challenges here.
Yes, I don't know the full details, but I've talked with a professor that I know, and she says that she feels like she can't hire PhD students because most of her grants don't allow it. So as far as I understood, she said she could only hire PhD students if she would set up a CDT, so a Center for Doctoral Training, which is like a more structured program. But their group, like it's a maths group, it's a bit too small for that.
Okay.
But she's otherwise a really good professor, so I felt a bit bad for her that she just couldn't take on any students, even though, I mean, she's obviously been a PhD student herself. But I don't know the specifics too much, but that was the inspiration for this question.
Okay. Well, thank you. I mean, I wonder if that's I wonder if that's a question then about how we support people who've got program grants or sub-program grants to take on PhD students. I mean, because I know it's quite a big, it's a big deal taking on PhD students in terms of the expertise and the institutional sort of support you need as part of it. Well, you're very welcome if you want to ask the lady you were speaking to drop me an email. ben.spence.mp@parliament.uk. And
that would be great. I think I can also reach out to the professor because I was first told that it would probably be too technical for this panel, so I didn't ask her the specific details, but I can reach out to her and then also come back with some more information.
Yeah, no, very much so.
Yeah,
Anyone else
thank you very much. That's great.
If you want to, if this is an issue for you as well, you wanted to raise with me, do drop me an email. ben.spence.mp@parliament.uk, but my emails are also publicly available if you Google me.
Yeah, great. And I'll send you an email later, but thank you very much.
Thank you.
Yeah, thank you so much. I'd say a massive thank you to Dr. Ben Spencer, MP, and thank you for your time. We've had some really interesting questions and some really interesting responses. So thank you so much. And obviously we will put you in touch with anyone that wishes to sort of follow up further on some specific questions. But thank you very much. And we look forward to working with you again soon.
Awesome.
I believe. Brilliant. Thank you so much. I see Patrick Vallance, Minister for Science, has joined us. So welcome, Patrick. Our first question is actually from some GCSE and A-level pupils from Bishop Hatfield Girls' School, who I'm going to read out for them. Do you think science should be separated from politics, or is that not possible, Patrick?
Well, I think it depends what you mean by it. So science ultimately, of course, is relevant to politics, as no doubt Ben has just said, and I'll say, because it's something that matters to government. It's something that matters to people. And so there is a political element to deciding how much you wish to spend on science and how much you wish to try and promote innovation. But of course, what there shouldn't be is politics in the process of scientific discovery and the answers that come up, which must be done in a proper scientific manner. And of course, there is a large part of the science budget which needs to be spent according to what researchers think is the right thing to spend it on. The curiosity-driven science, the investigations, the things that governments have got no real way of understanding. That should be driven by scientists and should be politically neutral and inquisitive in what it does.
I think our next question is Amelia from Applied Microbiology International. Do you want to ask Lord Vallance your question, please?
Thank you, Susie. So my question is that the government aims to optimise the use of antimicrobials by raising awareness of appropriate antibiotic usage across human health, animal health and agriculture. How can the government ensure that all sectors understand the severity of the threat of antimicrobial resistance to ensure cooperation?
Well, thanks, Amelia. That's a great question and a really important one. Antimicrobial resistance is a massive threat, and it's a real problem that society needs to grapple with. If we lose antibiotics, we go back to an era where people died of relatively trivial diseases because you simply couldn't get rid of the bacteria. So this is a massive issue. And that's why the government's taken a sort of One Health approach, looking across agriculture, food, animals, people. And that is essential, because if you don't do that, you don't solve the whole problem. And it needs to be a mixture of making sure that people are aware of antibiotic use. So there's a use question which needs to be dealt with. And there's, of course, a development of new antibiotics and other approaches, including vaccination, to try and make sure that we can actually have an armamentarium for the future as well. So it's appropriate use, and it's about developing new prospects. And I think there's a lot of work going on this across the world, including led by the WHO. And the government's plan of a national action plan runs from 2024 to 2029, where there's going to be a big push. And as you say, awareness is going to be a big part of that, making sure that people know. But I don't think there's anyone who really doubts the importance of this. It is a big change, though, and big changes are difficult, and they require public support. They require every sector to understand what they need to do, and this isn't going to change overnight. So it's an ongoing plan. It's a One Health plan, and it also importantly crosses all of the nations of the UK. This is something being done together, which is important.
That's great. Many thank you for that answer. Our next question is Nicola from the Biochemical Society. Do you want to ask Lord Vallance your question?
Thanks. Hi. The UK government has identified engineering biology as a critical technology. What steps can the government take to ensure the UK is world leading in the engineering biology sector?
Thanks, Nicola. And engineering biology is a technology which is here and now and important. It's a way of harnessing biology to use to do certain purposes. So it's changing biology from a sort of unknown certainty into a certain engineering problem, where you can end up with a product or an approach which allows you to do it reproducibly. And it's having an impact across everything from the obvious, like how you make new medicines or how you engineer new foods, or you do something with crops, through to different ways of manufacturing materials, making sustainable aviation fuels, making new materials that wouldn't exist in nature. So it's an incredibly important area. We're good at it in the UK, and the government is keen to continue funding all of this. It's why we put 100 million into this area in terms of the hubs that have been funded across engineering biology. So we need to fund this science and to continue making sure that is as strong as it can be. But, and this is really at the heart of your question, we need to make sure that the companies get looked after as well. And we've got lots of startups now in the UK. There's a reasonable amount of capital for startups, but we need to make sure that the capital is there for the scale-up companies as well, as they get to need more and more money, and that needs to be patient capital over many years. That's why we're looking at release of money from pension funds into innovative venture and other funds, in order to be able to give long-term, much bigger funding to these companies that require scale-up capital from the private sector. It's also why we've got the Regulatory Innovation Office, which has got engineering biology as one of the 4 areas that it's looking at to try and see what we can do to make the regulatory environment as good as we can, to be pro-innovation and allow these companies to have a cleaner, simpler path to approval of products without compromising safety along the way. And the final point I would make is that procurement is part of this, and making sure that government can use its procurement power to give certainty to some companies that they will have a customer if they end up with something that looks like it's valuable. So those 3 areas, coupled with a focus on skills and talent development, are the core of what we're trying to do, as well as funding the basic science. And getting the companies going is really a big priority.
That's right. Many thanks, Lord Vallance. We next have a question from Raushi from the Geological Society. Do you want to ask your question, please?
With extreme weather events such as heavy rainfall and drought becoming more frequent in the UK, and recent climate projections predicting a 20 to 35% increase in winter rainfall across the country by 2080, what steps can government take to ensure that scientific data and analytical insights are integrated into the UK's water industry investment programme for 2025 to 2030, and national risk mitigation strategies, particularly in context of flooding, landslides and slope stability that pose a particular threat to the UK?
Oh, thanks, Raji. That's a great and important question. You're right. Flooding and thinking about water are key areas, and science and evidence is going to be crucially important. In my last role as Government Chief Scientific Advisor, I pulled together a group of scientists and indeed some of the water companies to look at exactly this issue and ask what should and could be done, particularly using new technologies to allow us to monitor things better. The other piece of work, which is just reading out actually from the Government Office for Science, is a piece of work on the subsurface. In other words, what goes on below the surface that we all see, where of course water is a key issue. So there's work gone on there, and that report I think is either due out any minute or has come out. But I think it's an important topic. It's really important that the Environment Agency and the Met Office have a joint unit on flooding. And so that came about following floods probably nearly a decade ago. And that joint unit, based in the Met Office in Exeter, with people from the Environment Agency there as well, is an important way of monitoring things and knowing when responses may be required, but to make sure that policies to try and alleviate this are properly influenced by science. And there, the role of the chief scientific advisors in the departments is really crucial. And the fact there's a chief scientific advisor in every department means that DEFRA, of course, has a scientific advisor. There's a chief scientific advisor in DCIT who deals with the Met Office, and right the way across the department, this can be looked at, across the government, this can be looked at. So it is important to get this right, and there are some very good researchers in the UK working in this area. Not enough actually in hydrology, but there are more working in it than there were. And so I think we've got a good base to build on, but we do need to turn this into practical realities and to make sure that we understand what actions can be taken. So I think there's a lot going on. There are some reports coming out, and it is well understood that this is this issue of adaptation, not just mitigation of climate change, is firmly on the radar of government.
That's great. Many thanks. I've got a final question now for you from Jung Zeng from the Royal Society of Biology. Would you like to ask your question, please?
Thank you, Susie. So my question is that despite rapid advancements in biotechnology, translating groundbreaking research into viable products and solutions remain a major challenge. So what is government doing to help support the responsible development and implementation of emerging biotechnologies through fit-for-purpose regulatory, financial, and infrastructural systems?
Yeah, thanks, Jinseng. I think I sort of partially answered this in response to the previous question on engineering biology. So there are things that need to be done to make sure that companies are well funded, and then there are some things that need to be done in regulation. And the Regulatory Innovation Office is a great example of that. And they've recently given money to the Food Standards Agency to look at cultured meat and look at how you can do that in an effective way and regulate it in a way that's both pro-innovation and safe. And so there's a regulatory approach which is going to be important as part of the whole story in this, as well as the finance side of that. But there is a broader question then about the extraordinary advances in biology, which allow all sorts of things to be done easily now that simply were not easy or even impossible even a decade ago. So you'll be aware of the power of gene editing and the way that this can be done relatively easily by a competent postdoctoral scientist. That means that the ability to do things which you don't want to do is also easier, or you don't want to see happen. And so there is a responsible innovation group set up to look at exactly this and to say which are the areas that government needs to be looking at as these advances in biology occur that need to be thought of in terms of biosecurity, in terms of which regulations can be there that can prevent people doing the wrong things with this, whilst fostering the right innovation. And so this has been a great topic, including looking at things like, what sequences you might be ordering for DNA that might be dangerous in some way, and how you can do this. And there's a program that came out late last year illustrating how that should be done and how that could be monitored. We'll continue to look at these technologies, making sure that we get a good view on where risks lie. And we will also make sure that we have a very strong system, which needs to be a globally very strong system, for the security of laboratories that deal with this type of activity.
Thank you so much, Lord Vallance. Thank you again for your time this afternoon. And yeah, thank you so much for running back from a vote to take part and answer our questions from our early career researchers. Yeah, I think you've had some really interesting answers, so thank you so much. And
well,
yeah,
thank you.
Look forward to speaking to you again soon.
Yeah, thanks very much. Apologies about mucking you around on the time, and I hope everyone has a great afternoon with the other speakers as well, and get your questions answered.
Thank you very much. Our next session, we have Dr. Allison Gardner, Dr. Lauren Sullivan, and Emily Darlington, MP from the House of Commons Science, Innovation and Technology Select Committee. And I believe we are expecting, I'm not sure we quite have them yet, Viscount Stansgate and Lord Drayson from the House of Lords Select Committee as well. So the first question, which I'm going to put for Bishop Hatfield Girls' School, as they're in the audience here. So we've got some GCSE and A-level pupils. And the first question they would like to ask is, why do you think there is still a gender difference in the attitude towards science? They are obviously a girls' school. I don't know if Emily, you want to take that one first for us? Oh, we can't hear you. You might be on mute. I haven't said that yet today. No, we still can't hear you. No, we can't hear you. Oh no. Have we got I think we got Lauren or Allison from the committee as well on?
I'll jump in while
yes, excellent.
Her phone and Lauren, I'm sure, has a comment in. It's an interesting one. It's a long-held problem with lots of innovations to try and deal with it, but it's sort of fairly persistent. Interestingly, it's a girls' school that asked that question, because we know that there's evidence that you don't see that disparity in girls wanting to choose between physics and biology, for example. But you go into a mixed school and you do see that. So it's this concept of, what's for boys and what's for girls. But this starts very, very, very early on in primary. And so we need to really address the curriculum within primary, that we reduce that down. And I think one of the things that we need to do is address some of the imbalances in history when we talk about physics, that, you know, we don't always go on about Einstein, and that there are equally very, very famous and sometimes potentially more, I'm going to be radical here, but actually, you know, more innovative and groundbreaking scientists who go unnamed, that we could be referring to and use those as our examples. So this is not a new thing, but I think it's a very concerted effort that teachers need to do.
Brilliant, thank you for that. Have we managed to get Emily? Can we hear you now? No, we still can't hear you. Yeah, I think maybe Emily's going to try it and come back and answer that one for us. I'm not sure. Have we got Lauren?
Yeah.
I think we've got yes. Do you want to
Yeah.
come in there as well? Yeah.
Yeah, no, sure. So I used to be a chemistry teacher after I finished my PhD. So it was really cool to meet with youngsters who were interested in science, and teaching them from year 7 to kind of A level. It's an interesting space, and I think the curriculum's got a lot going for it as well that we need to kind of review and look at. We need to, I think, get the, well, for me, and certainly to my daughter, I would say we need to get the fun back into science. I was inspired to do science because we did about lots of practicals, and it was kind of quite logical, and you could kind of work it out as a problem solving thing. And that used a lot of coursework, but of course there isn't the time, or in the curriculum hasn't required the coursework. So I think I am definitely pushing to get some more coursework back in to get that hands-on skills experience. But in terms of the kind of gender pay gap, I suppose if you've got to go on to the next stage, we really need to do more to support our researchers in the parent stage of research. I mean, that's why I take a step back from research, was to have a family. We really need to help, but break through and support women and families progress through the science career, because it's such a fantastic career. I'll leave it there.
Thank you so much. Emily, have you managed to join us back again?
Can you hear me now?
Yes.
Okay.
Excellent. Yeah.
I've logged in on my phone because sometimes the parliamentary security just gets in the way of anybody being able to communicate. So I don't know what my colleague said. They're both fantastic women scientists. I'm not personally a scientist. I grew up in a lab, was very excited by it. But actually, the things I was most excited about in terms of engineering and others were taught in such a way that it was so alienating to me, and actually thought, well, there isn't a career for me here. And quite frankly, I don't want to spend my life in a lab. I'm too social of a person. And I think that is one of the major issues, is the science facilities that my daughters are being able to access are just not of the quality or the excitement or the science teaching that's needed to make them excited. And it's always about the teacher. If the teacher's excited about their subject, they'll be excited and they'll pass that on. And I can see it in my 14-year-old. She's got an amazing chemistry teacher, an okay biology teacher. Her physics teacher is not physics trained, and therefore she has absolutely no interest in the subject. Well, not the teacher, but my daughter, because she just can't see. And it's textbook, and it's not real life. And I think we fail boys and girls by not having better teachers. But I also think that we fail girls in a way that particularly on physics and maths, that you don't see that excitement. You just see those people that you want to become. Except we all just came back from CERN, and I don't know if my colleagues just said that, and there were some amazing women working at CERN. And so I would honestly say, please go into engineering and particle physics, because there's a real place for women in that.
Excellent. Thank you for that, Emily. We do have our biology school teacher of the year on the session with her pupils from Bishop Hatfield. So there are some very, very inspiring science teachers out there, but it probably might be useful to catch up with you some point about our concerns about the curriculum and quite how much stuff has been rammed into it, which possibly is removing the joy, I think, from teaching, because there's so much stuff that does need to be taught currently. Our next question, Joe from the Anatomical Society, do you want to ask your question, which is to members of the House of Commons Committee?
Hi, thank you so much for the opportunity to ask a question. Lovely to meet you. My question is, I understand that the Science and Technology Select Committee are running an inquiry into social media misinformation and harmful algorithms, while simultaneously the Department of Education has run a curriculum and assessment review. Across the media, one core component that's discussed as requiring greater emphasis within the national curriculum is critical thinking, either embedded within subjects or as a standalone subject. This skill is considered integral when assessing different sources, and I argue is of utmost importance in the current age of digital technology. Please, can you share your recommended actions which are being proposed to government in light of these reviews and the presented concerns? Thank you.
Thank you, Joe.
Who do you want to take that?
Yes, yes. Which one of you would like to take that, or a couple? It's up to you.
I'm happy to go first, and Allison and Lauren might want to come in. We've only gotten halfway through that inquiry, so we're not quite sure where we're going. Certainly in my mind, there's a real piece that's been missing, particularly from the Online Safety Act, which is what is illegal offline should be illegal online. Three of us are women politicians. You should see some of the stuff that we get through. Luckily, we're probably old enough and have a thick enough skin, having gone into politics. But you think about that environment for younger people, and it's sort of no surprise to me about how much mental health is being affected by our younger people. So I think we need to have a real discussion here, despite the push from the US that everything's about free speech. We have limits to our free speech in person, but we do not have limits to our free speech online, as it seemed. It's very much a self-regulatory environment, and it's quite clear that in that self-regulatory environment, the views of the owners and the views of the things that get the most advertising revenue, so the most engagement, seem to be the things that rule, rather than going after the things that actually cause damage to both mentally and ultimately physically, as we've seen. And there's just a little plug, there's a new Netflix show that's come out, and I've just forgotten its name, but it's all about that radicalization of young people online, particularly young men, and how damaging that is and what real world consequences that can have. And we have to be really serious about that. And I don't feel the social media companies in their responses to our inquiries have taken that as seriously as we need them to.
That's great. Thanks, Emily. Allison or Lauren, did you want to briefly come in on that point as well?
No, I'll try and be brief. Again, I don't know about the curriculum review. I think that's just closed, but I don't think we've had published responses from that yet. I was a teacher, and for many, many years, I saw the big difference. We started teaching a course called Horizons, which was basically philosophy and understanding the scientific method. But teaching this critical thinking skills was really useful. Now, if you look at the RE syllabus, they do an awful lot of philosophy in that. But unfortunately, it's badged under religious education, so I don't think people appreciate the critical thinking skills that is taught in there. Absolutely vital, the difference it makes. Then linking in with the online inquiry that we're talking about is for young people to be able to critically evaluate sources, and indeed adults now, and verify what they're doing, and really sort of think about where this information is coming and then be able to look at it objectively. I think it's vitally important, and I think it's really lacking, and I think we need to deal with that urgently. So I do hope it comes out in the curriculum review.
That's great. Thank you, Alison. Lauren, is there anything you wanted to add briefly to that? No. Excellent. In that case, shall we move on to the next question? So, Molly from the Association of Applied Biologists, and I wonder if you might want to ask this question to Lord Drayson, who from the House of Lords Select Committee, who we have on.
Great. Well, thank you very much for this opportunity to speak today. My question is, how can early career researchers best feed into policy decisions on topics within their expertise? For example, on the development of precision breeding gene-edited crops.
Hi. Well, I think that the best way to feed in is by participating in events like this. I think that having an understanding of the policy development process within Parliament and within government, and developing that understanding such that you can see when an event is being discussed. For example, when a committee like the Commons Committee or the House of Lords Science and Technology Committee are reviewing a particular area, what tends to happen is once the committee have decided that this is a particular subject that they want to do an inquiry in, they'll do a call for evidence. And if you're sort of switched on and paying attention to what's going on within the policy debates, that's an opportunity for you to submit evidence. It really is open to the general public. And if you regard yourself as having an important voice, some expertise in that area, or you're just concerned about that area, that's a great opportunity for you to make those points clear. Then what can happen is that you can be called to give evidence. I don't know if you've ever watched any of the parliamentary sort of live TV coverage of inquiries. I mean, they do actually make quite interesting viewing. And, I encourage people to actually tune into some of those. But coming to give evidence or tuning into the debate, and then, of course, writing to your MP or writing to members of the House of Lords in that particular science area, that also is an effective way of getting your voice heard.
Can I make a plug on the Commons side, something we're doing in the Select Committee at the moment?
Yeah, absolutely. Go on.
So we're really keen on people engaging with the Select Committee and to make sure that we're asking the questions and doing the inquiries on the things that you care about. So we've currently got a public engagement exercise called Under the Microscope, where we're going out to schools, but anybody can contribute to that. It's online. It's on the Science, Innovation and Technology page, Select Committee page. And so if you've got ideas of things that the committee should be looking at next year, please do submit them now. That this is exactly the right time to influence us and our thinking about what we're going to look at in year 2.
Thank you very much, Emily. So our next question, we have got Kathy from the Society of Radiological Protection. Do you want to ask your question?
Thank you. So the Society for Radiological Protection, SRP, recognizes the potential benefits of artificial intelligence across all radiological protection sectors, including industry, higher education, and medical, with the standardization and harmonization and efficiencies AI can bring to everyday tasks. SRP is keen to support the implementation of international best practice within the UK. How can the Society and other learned professional societies assist with the implementation of artificial intelligence in the UK and internationally?
Thanks, Kathy. And anyone interested from the committee and interested in taking it? Allison has got her hand up. Do you want to go?
I'm going to go a little bit away from politics actually on this one. Again, it goes back to Lord Drayson's comment about, please do engage with consultations and write to MPs and other stuff when key things come through. But I found in my personal experience, what really got involved was when I got involved in the standards world and developing technical standards. Now, it does depend on your scientific specialism, but with regards to AI, I started writing certain addendums to, there's a standard called well, I can't remember now, 14971, which is the use of digital technology medical devices within healthcare, and there was an addendum to that called 34971, which was about the use of AI in medical devices in healthcare, and getting involved in that and trying to influence the development on those, especially from an AI ethics and governance point of view, which is my specialism, was really influential. And you start getting in contact with quite a lot of people, and these things are listened to quite a lot, and some of these are national, such as BSI. You can be on various ISO boards, such as SC42, which is the AI one. You can be on specialist health ones, or whichever ones, but there's also other ones internationally as well. So ISO is international. Senelec is JTC21 committee. You know, trying getting involved in the standards world really has a little bit more influence than you think, and it's voluntary, and you can just join.
Thank you very much. Lord Drayson, did you want to come in there as well?
Yes. So I think this is a really vital area for your involvement, because the whole area of artificial intelligence is not only developing at a very fast pace. I mean, I've been involved in tech development for like 40 years or something. I've never seen anything develop as quickly as we're seeing generative AI at the moment, both in terms of the underlying foundational models, but also the applications to all areas of life, which means that it's becoming quite politicized, and sort of nation states, countries are trying to figure out how they can benefit within their society and their economies from the adoption of AI. And other countries are taking a more circumspect view, focusing on how can we make sure that AI is safe and that it is applied fairly without bias. And so it's becoming increasingly competitive, particularly between the companies which are sort of aligning themselves with the American government at the moment in terms of the way in which they're deploying their AI systems, and sort of the recent development of foundational models coming out of China, where it's regarded that the use of AI is really becoming increasingly aligned with government policy. So this is an area where the learned societies and the organizations which represent science have a very important role to play, sort of away from sort of the political considerations from a nation state, and being able to get their voices heard about how can AI be standardized, independent, if you like, of the politics, and to develop sort of aligned voices across science. Because at the moment, within AI development, there seems to be two schools of thought between the people developing AI, the ones who sort of have we've got to be careful, we've got to take step-by-step approach to its deployment, particularly in areas like medicine, and others that are very much forward-leaning, wanting to see the economic and growth benefits that come from its sort of rapid deployment. And so I think if societies which are independent of those sort of considerations can have their voices heard, this is a really important time for them to do it.
That's right. Many thanks, Lord Drayson. Shall we go on to Nicola from the Biochemical Society? Do you want to ask your question next?
Thanks. Hi. In light of the current funding crisis in British universities, what would you like to see the government do to ensure the sustainability of research careers in the UK?
I saw Emily had a hand up there. Do you want to go first on that one, please?
Sure. I think one of the most important things that we can do to create some stability in this area is do a 10-year funding settlement in terms of R&D, giving that long-term outrun. That's not going to get away from this whole 3 years, 3 years. It might make it longer, but one of the things that we absolutely know that there's a real inefficiency in the system where you spend the last sort of year of any kind of research bid looking for the next research bid, actually, and that's sort of the pattern that goes on and on and on. I think there's a couple of things going on beyond what happens in British universities, and it's one of the areas that I think we really need to look at with these high what do they call? We call them high talent visas, and how the visa system's working for that. But we also need to look at how we create sustainability in terms of the research. I presume we're talking about research funding given this topic, and I think the best way to do that is to make sure that the research councils, UKRI, Innovate UK, and others all have a much longer term understanding of their funding, and thereby being able to give that funding and long-term giving that understanding to universities, while, as I said, while the individual grants may not necessarily get to 10 years or anything like that, it starts to give us stability in particular fields of work and others, and understanding of where that's going. So that's where I would start, but I'm sure other colleagues have more specific elements that they would probably look at.
Thank you, Emily. Looks like Allison has got her hand up next. Do you want to come in?
So just really quickly, in the Science, Innovation, Technology Select Committee, we're also doing an inquiry looking at regional growth, and in discussions in that, some key points came up about how people's research careers develop. A lot of people will go to university, and they aren't all young 20-year-olds jumping from one university and free to move as and when they need to be, but they often have family caring responsibilities and are a little bit more geographically tied. And so we need to have a look at better funding within regions outside of key areas to make sure that when one funding grant, finishes after 3 years, that there is, further funding and further opportunities within that locale that they can stay to, if not in the university. And that was quite an interesting one. And as we look to develop, an industrial strategy, I think that's something that's been quite important.
That's great. Thank you, Alison. Lauren, did you want to come in as well?
Thank you. Yeah, very briefly, because I know there's lots of questions to get through. I think the Lord Vallance said something about pensions earlier, which I think will kind of unlock some capital, but also companies. So I've been in the university sector in the kind of research side. A lot of companies have pulled back their R&D, and looking at some companies obviously still do their R&D, but it's about that collaboration with companies, but also that return. So universities have done a lot in skilling up people as well as companies, but it's just trying to get the balance right so that there is a pipeline, a strong pipeline of talent coming through the system. But also just to do a big shout out to sadly to Dundee, who are facing some funding research issues, but 16% of their jobs in that area is science related. So again, it's trying to help that kind of ecosystem around research institutes, so that, as Alison was saying, there's space for people to go and continue their careers in science, whether that be in universities or in companies.
Thank you, Lauren. Yes, I think Nicola said yes. That's where she's based in Dundee. Yeah, thank you, Lord Drayson. Did you want to come in on that one, or yeah?
Yes. I think that the fundamental problem that the country faces in funding science at the moment is that the country is just not rich enough, because we've had a period of low growth and poor productivity. The ability to fund public services across the piece is extremely challenging, and that is only going to get harder because of the additional pressures that are coming from requirements to increase defence spending, for example. So the answer to your question really is for the UK to get better at generating economic growth, generating wealth, and the universities have a huge part to play in this. And one thing that we've seen over the last 20 or 30 years is that the university sector has got better at understanding how best to ensure that scientific research, which is funded from taxpayers' investment effectively, is translated into growth and jobs and creating employment and wealth in the United Kingdom. But it has sadly been limited by size, frankly. We've seen too often that UK science, breakthrough UK science, which has been taxpayer funded, has been spun out into companies which have then got to a certain size, and those companies have then acquired or they have moved overseas. And the lack of scale up investment for businesses in the UK and the way we've seen a flight of capital from the UK investment markets. I mean, if you contrast, say, 20, 30 years ago, where most of UK pensions were invested in UK companies, now most UK pensions are invested overseas. And so the work that the government's doing to see how that can be addressed is vitally important, because we've got to have the ability to continue to fund science. We're really good at science here in the UK, but we've got to make sure that the science which we develop, which then goes on to make breakthrough products, leads to commercialization, jobs and wealth creation here in the UK. And so that's down really to government policies to encourage investment, but also to be able to make decisions, for example, on the salaries that, for example, postdocs can get here in the UK. I know from one of my own children who's recently completed their PhD, she's been applying for postdocs. It's quite striking, the difference in the pay for a postdoc in the United Kingdom compared to countries in Europe like Germany and France. The postdocs are paid much more in those countries. And I think that reflects the sort of funding pressure which we're seeing here in the UK. We've frankly just got to make sure that we have the ability to fund these posts. And then there is the structure that ensures that the investment is there for that science where it has the commercial opportunity to translate into wealth creation here in the UK, which then creates wealth which can be taxed to continue to fund public services in the future.
That's great. Thank you so much for that answer. And yeah, it's increasingly challenging. And we certainly had a few questions raised on the issue of salaries for postdocs. I'm hoping we can maybe squeeze in a final one or two more questions. I believe Michael from the Genetic Society is in the pool, so his Wi-Fi might not be able to up for him answering the question. So I'm going to read it for him. His question was, genomics, especially when combined with AI, is becoming increasingly important in tackling major societal challenges such as human health and biodiversity loss. How can we ensure these complex concepts are effectively communicated to the public, and what steps can be taken to foster informed public engagement and trust in these solutions? If anyone wants to take that one.
I'll jump in on this one very briefly. There's a great organisation called Sense About Science, which I'm sure we've all engaged with at some point, who I heartily recommend. It's a fundamental, part of any science degree. I think that people who are learning to become scientists learn how to communicate it effectively, and I do sort of applaud that there is significant community, emphasis being seen on that. We've just seen Hannah Fry, haven't we, get a professorship at, I think it's Cambridge or Oxford, I don't know, but it's about communicating science. This is a real skill. And I know students, when I used to teach them, I was a lecturer as well as a teacher, they hated oral presentations and stuff, but you could encourage that way of communicating it really, really well and really, really simply. And I just think it should be integrated again, along with critical thinking, into the curriculum.
Brilliant. That is great, Alison. Did anyone else want to come in there? Otherwise, I will move to our final question. Emily, did you want to come in there?
Yeah, I just wanted to add, I think there is in an age where we're increasingly seeing people say, oh, we don't need experts. We actually do really need experts, and that involves scientists engaging directly about their work. And we've seen this throughout, in terms of the support for use of animals and experimentation, when scientists actually engage about what they're doing and why they're doing it, and what how they're doing it. It is absolutely essential that any science degree, quite frankly, in my opinion, but it would come from that, would be an understanding that part of the job is to engage, not just with the science community, but with the public on what you're doing. And I think there's a real benefit to that for us all.
I just make one cheeky comment. Because everybody always goes on about genomics. There's proteomics as well, and proteins are just as cool and sexy as genomics. So I'm just going to do a plug.
Excellent, thank you. I'm going to leave the final word to Bishop Hatfield's Girls' Schools pupils who want to know, is there an area of science that interests you the most? What's your favourite area of science? Lord Drayson, I'm going to put you on the spot there. What's yours?
Right now, I would say the use of artificial intelligence in society. It's fascinating and challenging and very exciting from a scientific point of view because the tech's moving so fast. And one that's really going to change society. So that's my current enthusiasm.
Excellent, thank you. Allison, do you want to go next?
Well, I would have to say AI as well, but within its applications, I'm a molecular biologist and I studied Alzheimer's disease and Parkinson's, and I still love things like microtubules and just the way that proteins behave within the cell. And I would love people to understand the inner world of the cell in as cool a way as they do other things. But so I stick to my original love.
Excellent, thank you. Emily, do you want to tell us what your favourite?
I have to say,
yes.
I'm gonna do a little bit of an opt-out and just talk about the whole field of personalized medicine and how that's going. And of course, that pulls in a whole bunch of what previous colleagues have said, but also talks about how the NHS will develop as a result, and the role between ourselves, our genes, and our personal responsibility when it comes to healthcare.
Brilliant, thank you. Lauren, do you want to come in on that one?
So mine would be about personalized medicine a bit, but more about the immune system and the immune response and that kind of that interface always between infectious diseases and our immune system and kind of populational health. So really, really cool, exciting stuff. And
excellent, thank you. Yeah, it's very exciting things happening in science. And Viscount Stansgate, I think you have just popped up as well, finally. Yeah, do you want to answer the final question on which area of science interests you the most at the moment?
Well, look, I'm sorry to be late. It's a terrible time for some of us to join you this evening because there are votes on a bill and it's interrupted my ability to be with you now. And there's going to be another vote any second now. And the other thing is I'm in a committee meeting officially, and it's on space. And when you think about space, the range of applications that are going to make a huge difference to our everyday life, health, Earth observation, sadly, defense and security, this is a really interesting area. And if this is the question from Bishop Hatfield's school, can I just say this? One of your questions was about strategies for getting girls interested in science. And we had a debate on International Women's Day a week ago, in which we discussed the role of women in science. And I got a very interesting and helpful submission by Professor Athene Donald from Cambridge, in which she said that you cannot begin early enough to shape the minds of young people and their interest in science. And if you start stereotyping girls from a young age, and I mean below 5, and say, oh no, boys do that, boys play with these types of toys, girls don't, then you're shaping from a very early age the attitudes and the capacity of girls to grow up to be women who do science as well as anybody else. So I think that's a really important question from Bishop Hatfield's school, and I'm so sorry that I haven't been able to say it before now, but at least I have. Thank you very much.
Thank you so much, Stephen. That's an excellent note for us to end on, I think. Yes, we really do want to inspire the next generation of scientists. And so we're very pleased to have our early career researchers with us on this session, and also the pupils from Bishop Hatfield's Girls' School. I'd like to say a massive thank you to all the politicians who've taken part, to Lord Patrick Vallance, to Dr. Ben Spencer, to Lauren Sullivan, Emery Darlington, and Allison Gardner from the House of Commons Science, Tech and Innovation Committee, and to Viscount Stansgate and Lord Drayson from the House of Lords Select Committee. Thank you very much to everyone who's taken part and answered your questions. And hope you've enjoyed the session this afternoon. We've had some really interesting questions and some very, very interesting answers from a very wide range of politicians. So thank you so much. And yeah, thank you for attending, and thank you for taking part, and thank you all for your time. And hopefully we will go forth, everyone, and inspire the next generation of young people in science.